Hey everyone and welcome. Have you ever written a line of JavaScript and just paused for a second, wondering what's really going on? How does that text you just typed actually make something happen on a web page? Well, today, we're pulling back the curtain on that whole process. We're going to dive into the fascinating high-speed magic that happens right under the hood. So, let's get into it.
And believe it or not, our entire story starts with something as simple and common as this. Just one line of code. Let x equal 5. It looks totally straightforward, right? But this one little instruction is actually the key that unlocks this incredible world of translation and optimization.
And that gets us to the big question, doesn't it? Your computer's processor, the actual chip doing the work, it doesn't speak JavaScript. Not at all. It speaks machine code, basically just ones and zeros. So how on earth do we bridge that gap? How does this instruction, which is perfectly readable to us, get turned into something a machine can actually execute?
Well, that translation step is the first huge piece of this puzzle. To get our code from our language to the computer's language, we need a translator. And for a long time, there have been two main ways to solve this problem.
So here we see the classic trade-off. In one corner, you've got the interpreter. Think of it like a live, simultaneous translator at the UN. It reads your code line by line and executes it on the spot. This is awesome for getting started really fast, but it can get a bit slow if it has to do the same task over and over again. In the other corner, you have the compiler. This one is more like a meticulous planner. It reads your entire program first, analyzes everything, and then creates a super optimized new program to run. It takes longer to get started, but once it does, that final program runs incredibly fast. So, which path does JavaScript take?
Well, the brilliant answer is, it takes both. Modern JavaScript engines are really smart about this. They don't make you choose. Instead, they use this amazing hybrid approach called just-in-time compilation, or JIT for short, to get the best of both worlds.
Okay, so here's how that magic works, broken down. First, the code gets interpreted, just like we talked about, for a super fast start. But while it's running, a profiler is watching in the background. It's looking for any code that gets used over and over again, and we call this hot code. As soon as a piece of code gets hot, it gets handed off to be compiled into a hyper-optimized version that can be used from that point on. It's this amazing system that gives you a quick start and incredible long-term performance. Now, the program that does all of this incredible work is called the JavaScript engine. There's one inside every single web browser. The best way to think about it is like a hyper-efficient office with a whole team of specialists, and each one has a really critical job to do. So let's meet the team. First up, you have the parser. This is the office gatekeeper. Its job is to read your code and immediately check it for any typos or syntax mistakes. If everything looks good, it creates this logical map of your code structure, which is called an abstract syntax tree, or an AST. Basically, nothing gets past the parser unless the code is written correctly.
Once the parser gives the thumbs up, that map goes straight to the interpreter. This is the enthusiastic new hire in the office who just wants to get the job started now. It takes that AST, turns it into a more machine-friendly code called bytecode, and starts running it immediately. This is what ensures your program starts up with zero delay.
Now, while the interpreter is busy working, the profiler is watching over its shoulder. This is your sharp-eyed manager. Its entire job is to spot patterns and find places to be more efficient. It identifies those functions or loops that are being run again and again, that hot code we keep talking about, and it flags them for an upgrade.
And that's when the office veteran, the seasoned expert, steps in, the JIT compiler. It takes that hot code that the profiler found and completely rewrites it into a highly optimized, incredibly fast version. It's basically like watching a manual, repetitive task get fully automated for a massive boost in efficiency. And what's the end result of this perfectly coordinated team effort? Well, your code runs. When you type something as simple as console.log hello world, this entire team, the parser, the interpreter, the profiler, and the compiler, all work together in literal milliseconds to get that message to appear on your screen. It's amazing.
Okay, so we've seen the engine and the team that makes it run. Now let's zoom in a bit and look at one of the most fundamental tools a developer uses every single day. The tool that actually lets our programs remember stuff: variables. So what exactly is a variable? Well, at its core, it's really just a named place to store something. The absolute easiest way to think about it is like a labeled box. You give the box a name, say X, and then you put a value inside it, like the number 5. From then on, anytime you need that value, you just refer to the box by its name. It's that simple.
Now, in modern JavaScript, we've got 3 main keywords we can use to create these boxes. The most common one you'll see is let. You use let for variables where the value inside the box might need to change later on. Then you have const, which is short for constant. You use this for values that you declare once and you never want them to change. And finally, there's var. Now, var is the old way of doing things and it has some weird behaviors, so for the most part, you should just avoid it in modern code. Stick with let and const.
Let's see this in action. It makes it way clearer. So here, we're creating 2 of those variable boxes. We label the first one x, and we put the number 5 inside. Then we label a second box y and put a 3 inside. Finally, we ask the console to show us what we get when we add the contents of x and y together.
And, no surprise, the output is 8. The program looked inside box x, saw a 5, looked inside box y, found a 3, added them up, and gave us the answer. Super simple, but also super powerful. Now, remember how we used the let keyword for y? That means we're allowed to change what's inside that box. So here, we're taking out the 3 and putting in a new value 10. Now, what happens when we run that same addition again?
The result is 15. The program looks inside x, still finds that 5, but now when it checks inside y, it finds the new value, 10. This ability to update variables is totally fundamental to how pretty much all programs work. All right, let's zoom back out for a second. We started this whole journey with one tiny line of code, let x equals 5. And now we've seen how that one little line kicks off this incredible, high-speed process with a whole team of specialists working inside the JavaScript engine.
And really, if you remember one thing from all this, it should be this idea right here. This hybrid JIT approach gives JavaScript the best of everything: the get-up-and-go flexibility of an interpreter and the raw optimized power of a compiler. It's just a beautifully engineered solution to a complex problem. So look at what we've just unpacked. In just the last few minutes, you've unlocked some serious knowledge. You now actually know how your code goes from being just text to a real action. You know the secret behind modern JavaScript's incredible speed. You've met the key players inside the engine. And you know how to declare your variables like a pro using let and const. So the next time you sit down and write a line of JavaScript, you'll know about the incredible, high-performance engine that's just waiting to bring your code to life. The only question left is, now that you've seen the engine, what are you going to build with it?